Okay. Uh, Chapter 1, Level M Chemistry. Um, I don't like chemistry. I hate recording it. But we're gonna let's go. I started at 5. Well, I just started recording now. So anyway, so chapter 1 is about Le Chatelier and equilibrium خرا. Uh, chapter 1, question 1. يلا. After the guy, if you don't understand, by the way, I did explain Le Chatelier and equilibrium in term 1 week, maybe term 1 week 3. Go to term 1 week 3 chemistry CA. I think that was it. Okay. You have N2 and 3H2, la, 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 la. So they said it's equilibrium. They said the total pressure is reduced. Shoot at the total pressure. Pressure total has been reduced. When you decrease the total pressure, the system has to increase total pressure. And it does that by going to the more gaseous modes. If you want to decrease pressure, the rule was if you increase total pressure, the system has to decrease total pressure, right? And to decrease total pressure, you go to less gaseous modes, okay? But in this case, they decrease total pressure. So أكيد نحن what do we have to do? The system has to do the opposite. So it's gonna increase total pressure. And how do you increase? نحن said to decrease, you go to less gaseous modes. To increase, you go to more gaseous modes. أكيد if you have more gases, then you're gonna have more pressure. Think about it like that. Okay, so here we're gonna shift to the more gaseous modes. Here you have 1 and 3, so that's 4. Here you have 2, so أكيد we're gonna shift backward. We're gonna go the backward reaction. It's not shifted, أكيد wrong. The pressure of NH3 is reduced. أكيد the pressure of NH3 is reduced because there's no more NH3, like we're decreasing. Okay, the system favors the formation of more H2 gas, أكيد since it's going backward, right? 2. Okay, select a picture that has equilibrium. The one that's at equilibrium has stuff going up, stuff going down at the same time. Okay, that's it. Here they're all going down, here they're all going up, here they're going down and up at the same time. Okay, that's what equilibrium is. Like if you look at the concept here, they said recognize that equilibrium, the condensation rate equals the evaporation rate. Okay. Question 3. Which of the following are true about equilibrium? أكيد we know macroscopic properties are constant. The pressure, the volume, the temperature, la color. The forward and backward reactions take place at the same time at equal rates, right? The microscopic processes continue to occur. أكيد we don't really see it. Both the reactions and products are present at equilibrium. The forward reaction is favored. أكيد this is not always true. It depends. Which of the following statements is true? 1 second. Is true about equilibrium. Both the reverse and forward stop when the system reaches equilibrium. أكيد غلط. The rate constants for both the forward and reverse reactions become equal. What is a rate constant? We did not take this, okay? A change in the amount. Wait. Yeah, the rates are equal, but the height is constant. What was it? Yeah, the rates are equal, and then you'll see now. The rates. We don't know what the rate constant is. I think that's why it's wrong. We don't know what the rate. We know equilibrium constant, but not rate constant. A change in the amount of solid in the reaction does not affect the equilibrium. We said the only change in concentration that we care about is, I think it was solids. I think it was aqueous and wait. Yeah. It's solids and liquids. They don't have a concentration. I think. Yeah, خلاص. I'm confident now. I checked it. Solids and liquids don't have concentrations. Only changing the concentration of the gases, and the aqueous will change the concentration. Okay. The equilibrium tends to favor the state of the greatest. No, it's less. Minimum potential energy. When Q is less than equilibrium constant, the reaction proceeds to the right. Yeah, this one just memorized, honestly. I think what they mean by Q is like the concentration, whatever. If it's less, they want to increase. Okay. I think what they mean is if it's less, and if the stuff on the left is less than what's normal, and if you decrease the stuff on the left, they have to increase it. No, actually, I don't know. Just memorize this one. If it's less than, it proceeds to the right. خلاص. Question 5. Lead chloride PbCl2 dissociates into lead chloride, whatever. The equation is shown below. This is it. Which of the following will alter the equilibrium? Okay, if we change temperature, well, the three things that can change equilibrium are أول شي concentration، تاني شي is pressure، تالت شي is pressure، وتالت شي temp. Okay, so changing the temperature أكيد is gonna favor depending يعني if you raise the temperature it's gonna favor the endothermic. If you decrease the temperature it's gonna favor the exothermic. If you add a catalyst we know it doesn't change the equilibrium. If you change the concentration of a product أكيد you change the concentration. Yeah, changing the volume نحنا we didn't really say anything about changing the volume. So no, changing the pressure. Why is the pressure here wrong? Pressure أكيد pressure غلط because you're not working with gases. Pressure is only for gases, right? Here ما في gases. Changing the volume of a container. I think كمان why changing the volume of a container is also wrong because احنا we know you can to increase pressure you have to decrease volume, right? A decrease in volume will cause an increase in pressure. I think in this case, if you change the volume, it won't affect it because we know that the only time pressure will change is if you have gases. Since we don't have gases, these two are wrong. I think. Yani. Question 6. Carbon monoxide reacts with hydrogen to produce methanol. Okay, the equation is this. Okay, which of the following would increase the concentration of CH3OH? So CH3OH, we want to favor it, so we're gonna go forward. What would cause it to go forward? Akid, adding catalyst doesn't affect. Decreasing the temperature. If you decrease, you're gonna analyze each one. Decrease temperature, you want to increase temperature, and if you increase temperature, you want exo. So we're gonna see. Is the forward? We want it to be forward. We want to see is this exo forward? It is. They put it in the product side magnet. The forward reaction is exothermic, so it's gonna favor CH3OH. If you decrease pressure, it's gonna go to less gaseous mode. No. If you decrease the pressure, the system wants to increase the pressure. And to increase the pressure, if you want more pressure, that means you want more gaseous modes. The more gaseous modes is here you have 2, here you have 1. So he's gonna go backward, and we don't want that. So هاي غلط. Decrease in volume will cause an increase in pressure. Okay, and the increase in pressure. Okay, no, that means system. Here I was first supposed system. The increase in pressure, that means the system has to decrease the pressure, right? To decrease pressure, the system will go to less gaseous modes, and we know it's the less is forward, so it's gonna go forward. Adding helium. Helium is an inert gas, noble gas. So noble gases don't affect anything. 7. SRSO4 decomposes into these two. The equation is this. Which of the following would shift the equilibrium to the left? They wanted to go backward. Okay. If you decrease the concentration of SRSO4, if you decrease the concentration of wait, how is that wrong? Concentration of SRSO4. Yeah, I saw it now. Before you even do this, before you check if it's correct or not, أول شي check is it a gas or aqueous. In this case it's a solid فأكيد غلط. Okay, you can't change the concentration of a solid. If you increase the concentration of SR2 plus, if you increase the concentration, and we're gonna write it in steps. Increase in concentration of SR2 plus means the system wants to decrease the concentration of SR2 plus. So Akid is gonna move away from SR2 plus if it wants to decrease, so it's gonna go to the left. صح? If you decrease, listen, before I continue, actually, no, let me finish this question. If you decrease the pressure is only when you want gases. Do I have gases? No. Decreasing the volume, again, decreasing the volume is like the same as increasing pressure. It's wrong because we don't have gases. Okay, no. Increasing the number of moles of SO4. If you increase SO4, that means the system, wait, I should have written system here. The system will want to decrease SO4. To decrease SO4, we're gonna move to the left. So akid, it's gonna be correct. So the wrong ones here are these 3. Let me explain something as if you get a question like this, مثلا like this in the written part, okay, and they say yeah, like this, in case it comes written. Anna, to be honest with you, I think Anna, I feel like the experiments will come written, the ones from chapter 9, those past papers. If you open, listen, I don't know, some people are gonna ignore what I'm gonna say now, but if you open the chapter 9 notes, I'll show you. Wait. Over here, if you open chapter 9 notes, we have a few questions at the end here. You're probably gonna get something like this. Uh, Maybe some graph or something. They won't tell you to graph. I doubt it. I highly doubt. But they're gonna get you questions like this, 100%. This timer question always comes. But they won't. I don't think. I doubt. Highly doubt they're gonna tell you to graph. But maybe they're gonna tell you to sketch. Okay. On all cases, على كل الأحوال, you're gonna have to solve. Make sure you know how to solve these papers. She's gonna get one question مثل ما هي وتكبها بالwritten. Okay. Make sure. Please make sure you know your stuff. Okay. يعني look انا تعبت والله ما عارف شو لكم. Physics قلت لكم you're gonna get PV over T. هلا okay. To be honest, everybody did good in the physics written. Math, I solved the exact written. I solved it in the live the night before. I told you guys, these are the ones that are gonna come tomorrow. Nobody listened to me. A lot of people did bad in the math written. Then for mechanics written, I told you guys it's gonna come copy paste from the past papers. It's gonna come copy paste from the past papers. Even after I told you it's gonna come copy paste from the past papers, people are getting zeros in the mechanics written, 1.5 out of 7 in the mechanics written. No, عيب. Wallah عيب. I'm handing you the written part. I'm telling you this is gonna come. People still ignore. إنه مش معقول. Anyway, I crashed out. My bad. بس my fault. Let me continue. But make sure you do this. It's in the chapter 9 notes for level L, grade 10 material. This one we did. Okay, yeah. Here, if that doesn't come, I was saying that if that one doesn't come, and they say مثلا, what would happen? Okay, make sure you know this. And I'm just saying this. I don't know if it's gonna come written, but if it does, if we decrease the concentration of, I don't know, SO4 to minus. This is what you're gonna do, okay? You're gonna write step 1, imposed change the decrease in the concentration of SO4 to minus. This is what you're gonna write. 2, to partially, or no, to counteract this, the system must, you put 2 dots, if it's decreasing, then to counteract, we're gonna do increase the concentration of SO4 to minus. Then we say 3, this is done by, and you're gonna write, now I want to increase SO4 to minus, so we're gonna shift it forward, right? So we're gonna say done by reacting more SrSO4 to form more Sr2 plus and SO4 2 minus, thus shifting it forward. Okay, before you're gonna say final concentrations. You can just write it like this, I guess. You can say concentration or write the symbol. You're gonna put SrSO4, you're gonna put Sr2 plus, and you're gonna put SO4 2 minus. Here you're gonna put it obviously decreased, right? We decreased. It went forward. SR2 plus أكيد it increased. وهون it's أكيد it increased because you moved forward, صح؟ but it increased, but we know it's gonna be less than, or no, just put increased. But you get what I'm trying to say. If it was the other way around, come on, same thing يعني. If they said instead of instead of decreased, if they said instead of decreased, increase مثلا, that means هون حتكون decreased, or no, هون حتكون increased, وهون حتكون decreased. Right? If it was the opposite. And it's pretty self-explanatory. And then to decrease SO4 to minus, it's gonna be reacting more SR and SO4 to form more SrSO4, thus shifting it all backward. Okay? These are very simple questions. And then the final concentration, أكيد this will increase, this will decrease, this will also decrease, but this one will be higher. You have to say this, higher than original. because here you increased it at the start. Okay, or less than original. You have hold up. Yeah, بتكتب higher than the original. Okay, this is in case it comes written. Come on, people who do IG cam, they need this. Anyway, how long have I been talking? 15 minutes. Which of the following would increase the yield in the above reaction? Okay, أعطوك delta H is negative يعني أكيد it's exo. Okay, let's see. If you increase the pressure, increasing pressure, that means system. Increasing the yield, that means they want it to go forward, by the way, huh? That's what increasing yield means. Increased pressure means the system must decrease pressure and goes to less gaseous modes. Okay, let's see. Here عنا 3, here عنا 2. أكيد it's gonna go forward. فأول واحدة صح. Let me change back to it. I don't like this color. Decreasing the temperature. If you decrease the temperature, معناتها the system must increase temperature. To increase temperature, that means it's gonna go to the exothermic side. ونحن we know that the forward reaction is exo. Correct. Decreasing the volume. Decreasing the volume is the same as increasing the pressure. We know بسرعة, you know increasing the pressure is correct and actually decreasing the volume is also correct. Because when you decrease volume, that means increase in pressure. Okay, wholly they're directly the same thing. Okay, no need to prove it. I just proved it in part A. Adding a catalyst أكيد لا. Adding inert gas لا. Okay, catalyst doesn't affect the equilibrium, neither does the inert gas, normal gas, whatever. Okay, A plus B, okay, whatever. What is equal when the reaction reaches equilibrium? What is equal? The things that when a reaction reaches equal, the things that will be equal are أكيد the rate of the forward equal to the rate of the backward. AMS question. اجت هيك وواحدة اجت هيك. بعدين كتبت هيك عملوا equilibrium وهون كانت forward rate هون backward rate. هيك كان. We know that at equilibrium the rates become constant. Okay. Then based on Le Chatelier, what will happen upon cooling the above system after it has reached equilibrium? Cooling يعني decreasing the temperature. Let's see here. They said it's given it's endothermic. Okay, it's given it's endo. Okay, they cool the system. Before looking at the choices, if they're cooling the system, يعني the system must increase the temperature. Or to increase temperature, it's gonna go exo. ونحن we know the forward is endo, so أكيد we're gonna go backward, right? We're gonna go the equilibrium shifts to the left. I think here I should have said, oh, never mind, I said it. Yeah, so it's gonna shift to the left. Let's see. The reaction produces more heat to re-establish equilibrium. True. ونحن we said we want to increase temperature. The forward is favored? No, no, backward. The system left? Yes. Mass of B stays the same as it is a solid. No, أكيد that makes no sense. The concentration of D decreases. أكيد yes, since we're moving to the left. 11. The reaction between nitrogen and hydrogen to form ammonia is very slow at room temperature. That's why they heat it up. The addition of a catalyst is necessary. The equation of the reaction is shown below. Which of the following happens when you add a catalyst? Okay, what changes when you add a catalyst? Do any of the concentrations change? No. La concentration, la pressure. Only the rate and of the forward and backward are altered, as well as the activation energy. These are the only three things that the catalyst affects. The rates, only rates and activation energy. أكيد at equilibrium the rate is equal at equilibrium of the forward and backward. Okay, هلا 12 أعطوك reaction again, nitrogen, hydrogen, ammonia. So they said predict what happens when you remove H2, so they're decreasing H2. أكيد the system will have to increase H2. So أكيد H2, if you want to increase it, you're gonna go backward. So it's gonna shift backward. So the backward reaction is favored. أكيد when it goes backward NH3 decreases. ما بدها هالقد. Questions should take you والله in the exam these questions should not take you less than 45 seconds. على السريع you read the question يعني okay reading instant reading was to solve it should not take you should not take you more than 45 seconds. A dynamic equilibrium is reached when the forward and backward occur at the same rate. Dynamic, by the way, means two things happening at once. نحن we have the forward and backward happening at the same time. The macroscopic properties are constant, right? But the microscopic are not. Don't put microscopic. It's an AMS question, by the way. A dilute yellow solution of this reacts with a colorless solution of this. Reacts with a colorless solution. Okay, لا 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 لا. Okay, so so okay عادة بيكتبوا لك الcolors بس here they gave it in the question. So ال FeNO3 is yellow. Okay, let me see. Okay, yeah. KSCN is deep red. No, sorry. KSCN is colorless. Deep red is FeSCN. So here it's deep red, any dark red. They want to know when it's gonna become darker. Okay. Okay, well you didn't put FeNO3, didn't put KSCN. Okay, انسى, just put red here. Okay, the color of the solution becomes darker upon when. Okay, when something becomes darker, yani the red color intensifies. So we want the red color to intensify. That means we want it to move forward. Let's see. I'm gonna explain the answer. I don't know what other choices they put, but if you add KSCN, that means the system has to decrease KSCN. And when it decreases KSCN, that means it moves forward. صح, it's gonna go forward. But if it moves forward, doesn't have to intensify the red color. Yes. If the color of solution becomes lighter هلا we want to decrease the intensity of the red color. So if you want to decrease the intensity, أكيد you're gonna go backward, right? نحن هلا we want to go backward. I'm gonna explain this. If you add Na2HO, okay. Yeah. So this compound here, sodium, I don't know, sodium something, sodium sulfate, I think. What it does is it decreases. You have to memorize this. It decreases Fe 3 plus. Okay, that's what this compound does. Okay, if you're decreasing Fe 3 plus, is a decrease. If it's decreasing Fe 3 plus, then okay, the system has to increase Fe 3 plus. Okay, and if we're gonna increase Fe 3 plus, that means we're gonna go backward. Okay, ونحن what do we want? We want to go backward أصلا. So going back will خلاص يعني بكفي. خلاص سريع. If you go back, أكيد it's gonna ignore the red color or become lighter. أكيد this reaction is reversible. Anything in equilibrium is a reversible reaction. أكيد it's reversible. That's why we put a double arrow. By the way, if for some reason I don't know you have written part وسألوك شيء عن equilibrium, please don't forget to put the double arrow unless you lose half a mark. Okay, double arrow. Equilibrium يعني double arrow. Normal reaction is yeah, normal reaction is a single arrow. Okay, نفس reaction here. Upon adding FeNO3, what will happen to the solution? Okay, again, this time they gave you colors. When you add FeNO3, what's going to happen to the solution? If you add FeNO3, okay, that means you're increasing Fe, right? If you're to counteract this, the system has to decrease Fe. To decrease Fe, we're gonna move away, so we're gonna go to the products. So we're gonna go forward. Well, okay, if we're going forward, yani it's gonna become darker, deeper. Ag plus, okay, before you continue. طب وليد, doesn't FeSCN contain Fe ions? يا أخي لا FeSCN هي ion لحالها. Okay, it's one big thing. It's one big thing. And I know some people are thinking, what's this stupid question, يا أخي? Why are you saying? But wallah, people ask these types of questions, and I'm serious. Ag plus ions react with SCN minus to form a solid AgSCN, which is insoluble in water. Upon adding AgNO3, the solution will what? Okay, so if you add AgNO3, they're saying that the Ag will react with SCN. So the Ag is gonna steal these SCN. So when you add AgNO3, you're decreasing the concentration of Ag, as the shoe Ag. You're decreasing the concentration of SCN. صح? If you're adding AgNO3. Or to do counteract, the system must increase the concentration of SCN. To increase the concentration of SCN, we're gonna go backward. If you're going backward, يعني it's not gonna be dark anymore. It's gonna faint. Faint يعني it becomes lighter. Question 16. Okay, oh my god, what's this? Write the net ionic equation. Okay, 15 milliliters of this is mixed with 250 of this to form this. Okay, okay, this is how you do this. You look at your precipitate, you see what do I have. ماشي. You have Fe, you have KSCN. Okay, very easy. KSCN نحن sorry شو KSCN, we have SCN and we have FE. Okay, so we're gonna put يعني ignore, imagine this isn't here. Okay, we're gonna put FE. أكيد ions are always aqueous. Whenever you're doing, the state symbols are always aqueous. Okay, we're gonna put plus SCN aqueous double arrow because this is in the computer. Double arrow, what do you get? FE SCN 2 plus. Command, it's an ion, so you put aqueous. But Walid, you're missing the charges. Okay, Habib, I know. I'm leaving it till the end. Some people, they don't have the charges memorized. Okay, well, that's completely normal. Very, very normal. It's fine. If you don't have the charges memorized, أول شيء, there are two things you can do. Go back to any other multiple choice question. 99% of the time, the charge would be in that question. Okay? If for some reason that doesn't work, you're going to look at the compound you have here. We know when you form a compound with two ions, Fe, okay, like, I don't know, CO3 2 minus and Na plus, you crisscross, right? You get Na2 CO3, right? You crisscross. So CO3 and then, yeah, you crisscross. So sometimes you'd be like, you'd look at this, you'd be like, oh shit, I don't know what the charge of Na is. Let me see. The charge of Na would be the subscript of the other one because it's crisscrossed. You gave, the Na gave the CO3 its charge, right? And the charge of CO3 in this case would be 2, right? Because the CO3 gave its charge down. So over here, and you have, when you have FeNO3, what do you think the charge of Fe is going to be? Fe gave its charge to NO3 as a subscript. Okay, so أكيد Fe would be 3. طب وليد, how do you know if it's plus or minus? يا حبيبي, come on, يعني it's a metal. Iron is a metal. أكيد it's positive. SCN minus. Okay, you can memorize this or you can see here. KSCN 1 1. يعني أكيد 1 1. طب وليد, sometimes if it's 2 2, then كمان it's like if it was 2 plus 2 minus, they're gonna cancel out. Okay, good point. صراحة very good point. Just memorize that SCN is minus. Okay. And I extended my explanation, but it's a very common mistake. The students they know how to solve, but they just don't know the charges. Haram, that's it's not nice. By the way, also, if you don't know if it's plus or negative, if it's the first one, it's always plus. If it's the last one, it's always minus. Okay. Calculate the number of moles. Okay, it's the same thing. Calculate the number of moles of Fe3 and SCN in the mixture. Okay. Now we have the moles of this. We have the moles of this. Okay, how do we calculate the moles of each one of them? Now we want to calculate Fe3 plus. We know FeNO3, if you dissociate it, this is from grade 9. I hate these types of questions, but yallah. If you dissociate it, you get Fe3 plus 3NO3 minus. Yeah. So now what do we want Fe. So okay, the moles of Fe, since it has the same coefficient as the Fe here, they're gonna have the same moles. How many moles do I have of FeNO3? Well, they didn't give it to you, but they gave you, Habibi. They gave you the volume, they gave you the concentration. You know, N equals CV. So let's just do it. N equals 0.02 times 0.015. Well, what is 0.015? يا أخي, عشان you make it liters. That's a meter cube, whatever. 0, you get 0.02 times 0.015. You get 3 times 10 to the minus 4. Okay, you get 3 times 10 to the minus 4 here, and since it's the same coefficient, you're gonna get the same moles. Okay, طيب. Okay, و 3 times 10 to the power of minus 4 mole. Okay, هلا SCN نفس الشيء. KSCN to be used K plus SCN minus. State symbols aren't required, we just want to see the coefficients. كلهم the same coefficients, so كلهم they're gonna have the same ones as KSCN. KSCN is gonna be concentration 2.76 times 250 milliliters, 0.25. Okay, 2.76 times 0.25, 0.69 mole. Ugh, what is true about the system? The reaction almost goes to completion. I think that's true for any equilibrium reaction. Oh. What they mean by completion is if you look at the moles here, this is so little and this is way big. Like this is way bigger than this. That means it's almost completion. But you know, when it reaches equilibrium, يعني خلاص, the reaction, the concentrations will remain constant. They won't change, right? So that's why what they're saying is it almost goes to completion. Is that before it reached equilibrium, it's almost finished. And look, Heidi, it's almost used up completely. Okay. The amount of KSCN is much larger than that of FeNO3. That's pretty obvious. The reaction is not غلط أكيد. The amount of this is larger than it. No, أكيد غلط. Okay. I hope this is the only question that's like this. I don't like these long questions. Oh, this is a nice question. Simple. What is the principle that says if the system is subject to a change, processes occur that counteract it? أكيد Chatelier. Right? Please, guys, in the mechanics or physics, ولا void, ولا I don't know, one of the periodics, I think it was physics, you had to type the law. People spelt it wrong and they got it wrong. Wallah, it's like you gave away 5 marks for free or 6 marks, or I don't know how much. You gave it away for free. Really, you gave it away for free. Guys, come on. I know. طب when it's a chemistry exam شو خاص English, man, they shouldn't give us English. يا أخي okay ماشي, بس I don't choose يعني. والله, if I could choose not to bring this, I wouldn't bring this. I'll bring it يعني multiple, بس إنه come on, you should be able to spell le Chatelier. Le Chatelier. وأصلا كمان it's in a different question 1000%. It's in any other question. Okay. 18. Okay. So I took 3 graphs and they gave us this graph here, this equation reaction. They're saying label each graph. Let's see here. The concentrations are both constant until أكيد we impose the change. Both I2 and ICL increased, but ICL increased, we increased it, then we decreased, right? So أكيد, why would you think this happened? I don't know. And then ICL began to increase later, right? When this started decreasing, this started increasing. It didn't jump. Okay. Imagine this. You increased I2 and then began to decrease. Why do you think? Because the system is counteracting the imposed change of us increasing. Whenever, if you ever see in this graph, if you ever see this type of question and you see this big bump, that means you're either adding or removing, okay, depending if you're going up or down. Okay. So here, أكيد we increased, we added I2. Here we decreased Cl2. Very obvious. Okay. Here, I2, ICL. Okay. أكيد it's going to be increasing the temperature because it's the only option left. But in case, you never know. In this case, the reactants are increasing. I2, concentration is increasing as ICL decreases. See? And it's not like a bump. No, it's slowly decreasing, right? So it's slowly decreasing. And honestly, the only explanation here, the gaseous moles, they're equal on both sides. So actually, it's not to do with the pressure. We know it's not to do with the concentration. What's left? Only temperature is left. Which way would favor the reactants, would favor the backward? Which way would favor the backward? If our forward is exo, right? Our forward is exo because it's releasing heat. Okay, that means our backward is endo, right? If our backward is endo, نحن we're going backwards to the endo direction. You know that when in Le Chatelier, you do the opposite. If we're going backward and we're going to the endo direction, that means we're trying to decrease the temperature. Why would we be trying to decrease the temperature? Because they increase the temperature. In other words, you can just memorize it. يعني خلاص, it's the last choice. Okay. Honestly, I'll do the same because it's logic. يعني I won't waste my time. But if maybe they get a question, and I'm here to explain, not to teach how to memorize. Okay. What is this, man? Phosgene COCl2 is produced by reacting during this reaction. Okay, given the graph below, drag and drop. Okay, at what time? Okay, at time I, what happens? Okay, at time I, let's see, at time I, we observe Cl2 had a lag, had a bump, had a spike. If anything has a spike, that means Cl2 was added. Self-explanatory. At II, over here. At II, CO began to increase, Cl2 began to increase, but the product began to decrease. If the reactants are increasing and the product is decreasing, يعني أكيد, if product is decreasing, يعني أكيد the reaction moved backward. Okay. Let's see from our choices what would cause the reaction to move backward. أكيد Cl2 is added wrong. Okay, temperature is increased. Let's see. If you increase the temperature, the system will decrease temperature. Or to decrease temperature, يعني they goes endothermic. Let's look at our reaction. Delta H is negative, meaning it's exo. ونحنا we want endo. So we're not going to follow the forward, we're going to go backward. Don't we want to see when it goes backward? Yes. So we just found when it goes backward, when temperature is increased. At time I over here in triple I, whatever you want to say, you can observe CO is increasing, Cl2 is increasing, and there was a spike or a lag in COCl2. Whenever we see a spike, اتفقنا, we agreed, that means you're adding it. So COCl2 is added. At time IV, what happens here? IV, CO is decreasing, Cl2 is decreasing, COCl2 is increasing. Okay, if product is increasing, yani it's moving forward. Let's see. The only other choice here, let's see. If CO is added, CO is removed, let me see. It can't be these two, even though they may cause it to go forward. It can't be these two because we said if something is being added or being removed, the graph would lag, right? It would lag or it would spike. Okay, in this case, mafi spike. So it's none of the added or removed or anything. So it's either temperature increased or decreased. Okay, it is decreased because the first one was increased. But let's explain it. Would it be temperature decreased? Why? If you decrease temperature, the system will have to increase temperature, meaning it's going to go exothermic. We know in this case here, the exothermic is the forward. So would it move forward? Now we're trying to find when it moves forward, right? Because we want the product to increase. The only time it moves forward, would it move forward if we want exo? Yes, because the forward reaction is negative delta H, it's exo. Question 20. Okay, you have this, okay, delta H negative, okay, they gave us the volume is 5. So I think they gave us the amount, yeah. So they gave us the amount of moles of HCl, which I think in this case is the reactants, O2, which is also the reactants. Yeah, okay. And then they became constant at some point here. Okay. Yeah, I guess this makes sense. When the temperature of this reaction is increased, what will happen to the equilibrium constant? Okay. Equilibrium constant I think is K, is Q, something like that. ما بعرف. But let's see. Oh, yeah. Equilibrium constant is K. You know that the equilibrium constant is equal to concentration of products divided by concentration of reactants. Let's see. If you increase temperature, increase temperature, that means the system will decrease temperature. System is going to decrease temperature. Or to decrease the temperature, it's going to go to the endothermic side. Here, it's exo. Do we want exo? No, we want endo. So what we're going to do, we're going to go backward. So it's going to go backward. If it goes backward, what's going to happen? More reactants, right? More reactants. So doesn't that mean the value of the denominator will increase? You know, if the value of the denominator increases, that means the value of your answer will decrease. So the equilibrium constant will decrease. For part B, I'll keep this. When the volume of the container is increased, so if you increase V total, if you're increasing the volume, you know that the pressure total will decrease. If you're decreasing pressure, increasing volume, decreasing pressure. Hold up. Yeah, sorry. I don't know why I stopped. I got confused. If you're increasing the volume, that means you're decreasing pressure. So what will the system do if you're decreasing pressure? The system will have to increase the pressure, right? And how would we increase pressure? If we want more pressure, that means we want more gaseous moles. More gaseous moles. Where do you have more gaseous moles? Here we have 4. Here we have 5. Yani akid, we're gonna go to the left, right? So it's gonna go كمان backwards. Okay. So the amount of Cl2 in this case, since we're going backwards, is gonna decrease. When a catalyst is added to the system, what's gonna happen to the equilibrium concentration of Cl2? Okay. When a catalyst is added to the system, we know when you add the catalyst, what happens? Nothing. Nothing happens. Literally, concentrations don't change. Okay. 21. How will the equilibrium concentrations change if NOCl is decreased in the following system? Okay. If you is decreased. Not did I say increased? I don't know. Anyway, if you decrease NOCl, a decrease in NOCl, uh, the system will have to increase NOCl. وأكيد these will both يعني it's gonna move forward, right? It's gonna move forward. It's gonna move towards it. If it's moving forward, يعني this will decrease, this will decrease. Very easy. How will it change if the partial pressure of O2 is increased? Okay, if the pressure of O2 is increased. I think this is the first question I ever solved on this channel, even though it's mentioned like 50 times in the book. There were many questions about it in the CQD, but it never came in an AMS, it never came in any CA quiz. Maybe we get it in the periodic, but let's see. This is the first time I work with partial pressure, okay? Even though I explained it before, but we just never got a question on it. When a partial pressure, when they say partial pressure, not total pressure, partial pressure of something specific increases, you treat it the same way as increasing the concentration of O2. Okay, that's the same. You treat it as if it's this. Okay, well, okay. If increasing the concentration of O2, the system has to decrease the concentration of O2. Oh, my handwriting is so bad. Okay, the system will decrease O2. ساعتها it's gonna move away from O2, so it's gonna go forward, صح? Away from O2. Okay. If we move forward, what's gonna happen to N2? أكيد decrease because we're moving away. What's gonna happen to NO? أكيد it will increase. يعني no ما في شك. Okay. Question 22. How will the equilibrium amounts change if the following gas mixture is compressed? هلا compressed يعني P total increases, right? عندك هالreaction هون. The amount of N2 in this case. Okay. Whoa, I lagged. Oh my god. Yeah. So sleepy. Okay. If you're increasing total pressure, يعني the system has to decrease total pressure. If you're decreasing total pressure, that means you want less gaseous modes. If you want less gaseous modes, let's see. We have 4 here, we have 3 here. يعني we're gonna go forward. So هون هنكتب forward. Okay. If you're gonna go forward, what's gonna happen to N2? أكيد it's gonna increase. You're going towards forward, and NO أكيد will decrease. يعني ما بدها القد. What can change? What are the things that can alter the equilibrium state? أكيد temperature, concentration, catalyst لا, inert gas لا. The other one after temperature and concentration would be pressure. Oh my god. And like I think they meant other than what was used in part A. Question 23. Okay, قربنا نخلص. How will the equilibrium concentrations change if the pressure is increased by adding an inert gas? Okay, see, they trick you here. They say pressure is increased, but you have to pay attention to the part where it says inert gas. Inert gas, constant. من الآخر, inert gas doesn't affect. It and a catalyst don't change anything except that catalyst changes the rate of the forward and reverse. Okay, but it doesn't alter the equilibrium. It keeps it at equilibrium. Okay, how will the equilibrium change if CO is increased? If CO is increased, let's see. An increase in CO means the system will have to decrease CO. If the system decreases CO, معناتها it's gonna move forward, right? If you decrease something, you're moving away. It's moving away from CO, so it's gonna decrease. No, it's not. Sorry, it's gonna increase CO2 and NO. I thought they asked about NO2 as well. Okay. Okay, how will the equilibrium amounts change if volume is decreased by removing water from the system? If, let me see. شو water? Follow, شو water? I think maybe they mean solution. Yeah, I think they mean solution. Okay. If you're removing water, you're decreasing a liquid, right? Now we said this increasing, decreasing, removing concentration, whatever. It only applies for gaseous and aqueous species, right? It doesn't apply for solids and liquids. So since it's a liquid, constant. Okay. How I should put check. I don't know why I put X. How will the equilibrium concentration change if the mass of AgCl is increased in the above system? AgCl, what is it? Solid, constant. Like I said, very, very, very easy. 25. How will the amount of H2 and H2O change if the pressure is doubled in the above system? هلا it's gases, so we can actually see. If the pressure is doubled, so P total is increasing, that means the system must decrease P total. To decrease P total, it's gonna go to less gaseous modes. To go to less gaseous modes, you have 2 here, you have 3 here. So you're gonna move forward, right? So if you're gonna move forward, what's gonna happen to H2? Decrease. What's gonna happen to H2O? أكيد increase. Okay, if you add argon, for those of you who don't know, argon is a noble gas or inert gas. You know, if you add a noble gas, it remains constant. Please, if you see a name of a gas, please don't panic. 1 second. Yani, if you see a name of a gas, yani, please just go here, go to your periodic table, which you will have in the exam. Look here and go down all the way. Don't you see argons here? These are all the noble gases. You see them here? Yani, it's a noble gas. They might say addition of xenon, addition of ما بعرف شو. Just know, check if it's a noble gas. Okay? Question 26. Consider this. Okay. What will happen if pressure is halved? يعني P2. Okay. عندك gas. Okay, look, gas. If P total is decreased, system will have to increase P total. If you want to increase pressure and you want more gaseous modes. Where do you have more gaseous modes? You have 1 here, you have 1.5 here. Or you could just say 1.5. Akid is going to go to the left, so it's going to go backward. If it's going to go backward, Akid O2 will increase. If it's going to go backward, Akid SO3 will decrease. Okay. What will happen if temperature is increased? Okay. I don't know. Let me raise this. If you increase the temperature, yani the system will have to decrease temperature. To decrease temperature, that means we want endothermic. Hon, the reaction is exothermic. This is exo. The forward is exo. Now we want endo, so we're going to do the backward. So that means we're going to go backward. If we're going backward, what's going to happen to O2? Command increase. What's going to happen to SO3? Command decrease. And there was a question like this in the exam where it was like they were both increase, decrease, increase, decrease. So I stayed on it for like 4 or 5 minutes because I was a bit sketched out. No, I was like, no way, no. She puts 2 answers. نفس الشيء. What about? But don't do the same mistake I made, guys. She will. She did put 2 answers. What about? Question 27. Okay, these questions are easy. Reaction gas, but this time it's endothermic, because it's on the reactant side. How will the equilibrium change if volume is increased? An increase in volume means a decrease in pressure. And if you have a decrease in pressure, the system must increase the pressure. That means it's going to move to more gaseous modes. In this case, you have 1, you have 2. So we're going to move forward. Okay, if we're moving forward, what's going to happen to NO2? Akid is going to increase. What's going to happen to NO4? Akid is going to decrease. And these are self-explanatory. If temperature is decreased, so you have a decrease in temperature. And decrease in temperature means the system must raise the temperature. Well, if you want to raise the temperature, that means we want an exothermic. We know that the forward here is endothermic. We want exo. We don't want endo, we want exo. So we're going to go backward. Why some people still to this day they get confused? What do you mean backward? If you're going back, you're getting energy, man. No, man, don't. Please. This doesn't mean you're getting energy. This just means that the forward reaction is endothermic. It depends. If the energy is placed in the reactant side, that means it's endothermic. If energy is placed on the product side, the reaction is exothermic. Okay, man, if delta H is positive, it's endothermic. If delta H is negative, it's exothermic. Okay, ماشي. So we're gonna go backward now, since we said we want exo, and the forward is endo. We want exo, so we're gonna go backward. Again, if we're gonna go backward, N2O4 will increase, but NO2 will decrease. Question 28. Okay, gas. Okay, number of moles of NH3 is increased. If that means you're basically increasing NH3. If you're increasing NH3, that means the system must decrease NH3. What's gonna happen if you're gonna decrease NH3? We're gonna move backward, right? So we're gonna move backward. If you're moving backward, H2 will increase, N2 will increase. If a catalyst is added, constant, right? Honestly, صراحة guys, after this chapter 1 quiz, if you like ما خلوا سؤال, like you put like the same question maybe 9 times, إنه خلص they مصرين بدهم يحفظوكوا القاعدة. إنه in English, I don't know how to explain what I said in English. I think they're very focused on making you want to memorize the rules, if that makes sense. اوكي عندك هون reaction اعطوكوا دلتا H is positive ف يعني it's endo, the forward is endo. Okay. So they give you a change and you're gonna have to say okay. If you add H2 I'm gonna put system. Okay, I'm gonna put a system column because ما بدي اكتب system 4 مرات. Okay, system هون هحط 1 2 3. I'm gonna put yeah forward yeah backward, right? Okay. If you're adding H2, what's the system gonna do? Decrease H2. Now we want to decrease H2. If you want to decrease H2, you're obviously gonna go backward. So it's gonna shift to the left. What happens when you shift to the left? What happens to H2O? Obviously it increases. What happens to O2? Okay, it decreases. Adding He. He is a noble gas. No change. Okay, since it's a noble gas. So unchanged, unchanged, unchanged. If you increase the temperature, we have to decrease the temperature. In other words, endo. Let's see. We want endo. We know that the delta H is positive, so the forward is positive. So if you want endo, we know the forward is endo. Yani, okay, we're just gonna move forward. We're gonna shift to the right. What's gonna happen to H2O when you shift to the right? It decreases. What happens to O2? It increases, obviously. Okay, they gave you another reaction in part B. What would decrease the concentration of CO? Decreasing CO, yani in other words, they want to move away from CO, so they wanted to move backward. Okay, what would cause backward move? If you add H2, you're increasing H2. Akid, we want to counteract. I'm gonna put again system here. It wants to decrease H2. To decrease H2, you go backward. So that's correct. If you're decreasing the temperature, what will the system do? It will increase temperature, and it wants exo. In this case, it's endo, so we want to go backward. Since the forward is endo, we want exo, so we're gonna go backward. We want backward also. It's correct. If you add carbon, what will the system do? It's gonna decrease carbon. If you want to decrease carbon, it's gonna move forward. We don't want forward, so this is wrong. If you add catalyst, أكيد غلط. Increase the temperature, that means it wants to decrease the temperature, so it wants endo. أكيد if we want endo, we know that the forward is endo, so it's just gonna go forward. نحن ما بدنا هيك, we want it to go backward. Okay, last question. It's almost 50 minutes recording, I think. Right, equilibrium. Okay, this is very easy. Okay, equilibrium law. Equilibrium law is concentration of products divided by concentration of reactants. Okay, let's see. Here, only applicable for aqueous and gases. Okay. Solid, we don't count it. Liquid, we don't count it. So what do we only have? We only have, I think they give you K equals Cl. They give you the K equals. You put square brackets for concentration, and you put Cl2. Very easy, right? And there's nothing to write. Don't put state symbols unless they ask you to say state symbols. Here, liquids we don't want. So it's gonna be, what are my products? You're gonna write concentrate. They give you K equal H2 O2. But you have a 2. If you have a coefficient, you raise it to the power of that coefficient. That's it. Okay? Very easy. Here, gas, so we don't care. So you're gonna put product NO2 raised to the power of its coefficient over reactant N2O4. Doesn't have a coefficient, so that's it. Thank you so much for watching. Good luck in your exam.